25 slides. So yeah, I'm just going to be working off of all of the review slides that were posted on web courses for your class. So I'm going to name some topics, and if you want me to talk about them, I can. If you don't want me to talk about them, then I'll just skip over them. So the first one here is naming conventions. Is that anything that you think is important? Slides. So yeah, I'm just going to be working off of all of them. You're good. So stuff like, should you capitalize the names of variables and methods and classes? Okay. Then yeah, identifiers, which is just like how do you name your variables? That's not super important. So yeah, the first actual worthwhile thing on here is access modifiers. So you know that we have public, private, and protected. Public means accessible everywhere. Oh, the whiteboards are like weirdly aligned. So a method or a variable that is public can be accessed from anywhere in your program, like from outside of the class that it was made in, inside the class that it was made in. It doesn't matter. It's public. That's what it means. Private is pretty much the opposite of public. It is only accessible inside of the class that it was made in. So if you have private data in one class, you can't access it if you instantiate that class in another class, unless you have some other method for accessing that data. And then protected is sort of a mixed access modifier. It works mostly like private, but it's also accessible inside classes that inherit anything that is protected. So if you have a parent class that has protected data or methods, then its child class will also have access to those protected data and methods. And then there's one more state that's worth mentioning, although I doubt you'll see it at any point because there's no real reason to do this. But if you don't put an access modifier, then it is like public, except it's restricted to the package you're working in, which is typically the entire program that you're writing. So yeah, that's it for access modifiers. Should be super familiar with them. Then there's also like how to format naming a class. So obviously access modifier first, and then the keyword class, and then the name of your class. And then I guess I can also mention, just like in general, how I like to visualize what writing a class is like. Whenever I do conceptual examples, this does not erase very well. Maybe I should just write on my paper. And if at any point you realize that all of this stuff is stuff you know very well and it's not worth me talking about, just let me know. But whenever, this is weird, I've never done this. Whenever you make a class, I like to see it as this. And normally I would put, like, I guess I can write class name. And then you would have your data in some kind of list here. And then you have your methods in some kind of list. Just so that you're aware of how a class, That is hard to read and also very small. I'll do better. Just so that you're aware of how a class contains things, so that when you start working with multiple classes, it's easy to see the relationship between them and it's accessible where and so on. And I'll get more into that in one of the later topics. Then there's also method format. If you know how to write a function, you know how to write a method because they're the same thing. The only thing that's different in Java is having an access modifier first, and then whatever special keywords would go between the access modifier and the return type, like abstract or static or something like that. Then we have variables and data types, which I'm not going to go over because, and arrays, all of that stuff you should know from Intro to C and have practiced a ton in this class anyway. The next thing is enums. Just because, well, this isn't unique to Java or object-oriented programming, really, but it's the first time you've probably seen it in this class. So, how big should I write? So the example here is and the way I think of enums is just they're a numbered list. Like the names are only there for reference. You represent as like option 1, option 2, option 3. So you use them to select cases and conditions that you're working with. And the names are just a convenient way to refer to them so that they have direct, instead of just creating a set of integers that have values 1, 2, and 3. This is just sort of a shorthand way of doing it. I'm not going to go over how to do comments or how to use scanner. I will go over just in general instantiating a class as an object. So I'm going to use the scanner example because it's the first one here. So if you have class scanner imported in your program, then to instantiate that class as an object, you write the name of the class, where you would typically write the type for your variable, and then the name of your object, which in this case, just for typical naming conventions, if you only are going to use one instance of this class in your program, it's totally fine to just use the name of the class, but start it with a lowercase letter just so you know very directly what you're using. And then the new keyword and then the constructor call. And in this case, the scanner can take system.in, which is user input. And so the constructor call is the thing that sets all of the initial conditions for this instance of the class. The new keyword is the part that allocates memory for this specific object. And then the assignment operator tells the name of your object where its associated memory is going to be located. So when you use new, it actually returns an address to this location, an address from memory that gets assigned to the name of your object so that it's always referring to the same place in memory. Not sure if that was ever gone over in that much detail in your class, but I think it's worth knowing. And then there's, printing output, what operators are and how to use them, like equals and less than, and not and or. Those should all be really familiar. how to write loops for and while using if and else conditionals. None of that stuff is super important for this class. Okay, so I'm going to move on to actual object-oriented stuff now. Hopefully, by this point, we're all good enough programmers where we can make use of this stuff. So I wrote this thing that pretty much says, why is object-oriented programming important? And I know that you've had some short response questions on your tests. I doubt this will be a question on your final, but I'm going to go over it anyway. The general answer to this question is because you can use something called encapsulation. And this sort of gets to what I was talking about before with why when I visualize the properties of a class, I draw it inside of a box. So encapsulation means that there are sort of two sides to what you're doing when you're writing programs using an object-oriented approach. So you write a class, and it has data and methods, and most of that is probably going to be private, and then you're going to have some public methods that can be accessed from outside of that class. And you're going to use instances of that class throughout your program to accomplish some goal, like do mathematical calculations or solve some logical problem. So the reason why this is important is you can separate the way the program works at its core with all of the things that it needs to do and make use of to solve its problem. So if you have some object that does some sort of math and you need to do that math a whole bunch of times, then you can instantiate one copy of that object into your program and then use its functionality and its data as many times as you need to solve your problem. Whereas in a linear programming approach, you would need to create new variables repeatedly, call the same function over and over. So this is a way of making problem solving a lot more efficient. Another good purpose for encapsulation is if you're working at a company that has multiple people on a team creating some software, it's easier to separate responsibilities across people because you can have one person working on the implementation, like writing the core classes that are going to be used in the program. And you can have another person working on the API and like the general public-facing part of the code, like making use of the classes. So it's easier to separate tasks across people with this approach as well. And then there's sort of just what is in a class. I kind of already went over that. There's a class, it has a name. Inside of it, it has data and methods. Those data and methods can either be public or private or protected in specific cases. So it should be pretty well known by now what an object is. An object is an instance of a class, and then you would call the object's constructor when you create the instance to set all of its initial properties. Okay, so first, really serious topic, inheritance. So inheritance in Java means there are classes that are derived from existing classes. So normally you'll have a superclass, which I prefer to refer to as a parent class, and then you have derived from it a child or subclass. And the child class will inherit all of the data and methods from its parent. So the way I like to visualize this is you'll have your so this will be the parent class. And when there's a child class, I draw it around the parent class. Just to demonstrate that the child class contains everything the parent class has. So when you're referring to data, you can refer to the names of all of the data in both the parent and the child at the same time, and then same applies to the methods. And so the child class will always be a specialized version of the parent class that needs additional information and additional functionality to achieve its purpose. I'm going to go to another page. So there are also abstract classes. So one of the things that may be unclear when you look at an abstract class is what is its purpose? So an abstract class is typically designed as a parent class. And it contains a bunch of abstract methods. And so an abstract method will be a method that contains no functionality. And so the way that you make use of an abstract class or a class that contains some abstract methods is that all of the children of this parent class that has abstract methods in it have to re-implement and override all of the abstract methods in that class. So in this scenario, we have, say, this parent class, and then several child classes. They're all going to have an override for this do math method. All right. And the reason you would create something like this is you know that all of your child classes are associated in that they share properties with their parent, but they all need to implement this do math method in a slightly different way. So maybe for the correct calculation, this child needs to add 5, the second child needs to add 6, and the third child needs to add 7. But the intent and design for that method is the same across all of the child classes. So it's a way of guaranteeing the existence of specific functionality across all of the children of a parent class. So, for example, if you had a shape parent class, you could have an abstract method that is a number of sides. And then for all of the child classes, like one of them is circle and one of them is square, then you could set this abstract get number of sides method to return 0 in the circle child and return 4 in the square child, and so on. So you know, no matter what type of shape you're working with, you'll always be able to get how many sides it has, but you have to write it differently in each of the children. And so that leads into interfaces, which serve almost exactly the same purpose, except that the abstract part now exists separately from the class. So instead of requiring this design where you have a parent and then you have a bunch of children that inherit this abstract property, you now have an interface which becomes implemented into the class. So if we have an interface called buffer, then you would have, public class name implements. I didn't give myself enough room. You get the idea. All right, so that's how you would implement an interface. And the interface serves the exact same purpose as all of the abstract methods that would have been in the parent class in the other example, except now they don't need to be associated with the class to be used. And the purpose is still the same, is that any class that implements an existing interface is guaranteed to have some version of all of the methods that are in that interface. So you know immediately when you see the class what sort of functionality it can provide. And it is overridden in the exact same way that you would do so with abstract methods that are inherited. Hi. There's also the topic of polymorphism. So this pretty much just means you can treat associated classes in a way where they're all the same thing. So if you have, again, shape, and then shape has a bunch of children that are different shapes, then all of the children of shape are shapes, and you can refer to them as such. Also with interfaces, since you're guaranteed that methods from an interface will be implemented, you can refer to a class that implements an interface as the interface itself. So there's this example here. I'm just going to write out part of it. And then I'm not going to write the constructor here, but this is the constructor. And then there's this show method that just, I'm going to shorthand this. It prints the number of wheels that the vehicle has. So we have this vehicle parent class, and then there are 3 child classes. One of them is truck, which extends vehicle. One of them is car, which extends vehicle. And another one is taxi, which extends car. So all 3 of those, truck, car, and taxi, are still vehicles. They all inherit the properties of vehicle at some level. So you can refer to all of them as vehicle. So ultimately, you end up with, you can make a vehicle array and in one slot in the array, you can instantiate a car object and put it in the array, even though the type of the array is vehicle. Because car inherits from vehicle, this will work. And then the same for truck, and the same for taxi. And then even though this is something that works, you'll be limited in functionality because now all of your different vehicles with different data and different methods are part of this vehicle array. If you want to access the contents of the vehicle array and do the same operation on all of them, you're restricted to whatever vehicle is capable of on its own. So from before, vehicle only has the number of wheels, its constructor, and then the show method that just prints the number of wheels. So in this example, we write a for loop that cycles through all of the elements in the vehicle array and since we can guarantee that everything in the vehicle array has at minimum that show method, you can call the show method on every vehicle in the array. However, because each of the vehicles has a separate implementation of the show method relevant to each vehicle will be called. So when it calls show on car, it's going to call car's show method, which says I am a car that can carry 5 passengers, right? It just has a different printed message for each of these 3 things. But because you know that all of them have show, you can call show, if that makes sense. You can only refer to the properties of the shared properties of all of them when you're working with all of them at the same time. So I mentioned earlier this override thing where you write the @ symbol and then you write the word override. This is something that's not actually necessary in your code. It's a message for the compiler, but your program will work without it. The purpose of the override tag is just to say, this is a place where an override is going to happen, meaning I am rewriting an inherited method from either an interface or a parent class. So there's like an entire bunch of slides on this. It's really just a tag that you write in front of any method that you are re-implementing that is inherited. I guess the important thing here is not to get confused between overriding and overloading, because they are two extremely different things. So overloading is when you have multiple methods that have the same name and the same intended functionality, but they have different lists of arguments. So the inputs to those methods are different. So let's say you have a method called maximum that returns whichever number is the higher number. And it will always convert the higher number to an integer, just for the sake of simplicity here. You could have one version that takes two integers. You could have another version that takes two floats. You could have a version that takes an integer and then a float, or a float and then an integer. So you can have any arrangement or any number of inputs, but the name of the method will always be the same, and the intent of the method will always be the same, meaning it will always do basically the same thing with slightly different implementation depending on what the matching list of inputs is that you write. So the way this works is if you have something that has some variable set of inputs like this, where you want to write functionality that can handle any combination of number data types, then when you write your call to that method, it will automatically find the matching implementation and call that one. You don't need to do anything special to make it happen. Just if you write maximum and you give it two integers, it's going to call the one that works with two integers, and so on. Okay. Now moving on to what is classified under special topics. So in the case that you need it on your test, which is very likely because you did it all the time in this class, I'm going to talk about ways to generate random numbers. You probably won't end up writing something in like a code writing problem, but it's very likely that you'll see this. So there is this random class that you can import, and just like instantiating any other class, you call its constructor and use new. And so there are a couple ways to generate random numbers. The most common one that you'll see is the name of your random number generator, and then the dot operator, and next, and then whatever data type you're looking to generate. So by default, if you call the one that has no input, it's going to generate any number that can fit inside of the memory for that data type. So next int can give you some crazy number in the millions or in the negative billions or whatever nonsense you end up getting from that. So if you're looking to generate reliably random numbers, then that's a good way to do it. However, most of the time, you're looking to generate random numbers within a specific range. And you would do that by putting a numerical input. So this is actually a really good example of what I was talking about before. This is what method overloading is, right? You have the same name twice, but with two different inputs, and they do different things depending on which type of input you give. So this one will generate a random number between 0 and 9. So it'll always start at 0, and it will always go up to the number before the number that you've entered. So what this really means is you're not asking it to generate a random number up to 10. You're asking it to generate a list from a list of random numbers that is size 10 and starting at 0. So if you wanted to adjust the range of random numbers, say you wanted it to go from 10 to 19, then you would generate some random number on the list of numbers 0 to 9, and then just add 10 to it. So then you're going to get a shifted range of 0 to 9 plus 10, which would be 10 to 19. And so I think it's pretty simple to figure out how you could generate any range given this example. And even if it doesn't come up on the test, it's worthwhile to know just for general programming use. I think it's also useful to know a few things about how to work with the string class. So strings have a bunch of really useful things built in. So the most common one that you'll probably see and that I believe you've used in this class before is substring. And there are two versions of substring. One, you give a single number, and one, you give a pair of numbers. The first one will give you the string starting from the index that you give all the way up to the end. So like if you imagine a string as an array of characters, it will find this index in that array of characters and give you back whatever is left of the string starting from that index. The second one will only return the range of characters from the first index to the second index. So this means just like with the random number generation where it'll go from 0 to 9 when you give it 10, this 5 to 7 example will give you 5 and 6. So you're determining a starting point and the end of the range. It will not actually give you that higher number that you put. So maybe you'll see it in your test, maybe you won't. I know you've used this before to solve some problems in your homework. Then there's also equals, where you can compare if two strings are the same. You have char at, where you can find the index of a character. You have replace, where you put in either two characters or two sets of characters, and it'll search through the string and replace all the instances. And then you have stuff like two uppercase and two lowercase. None of that is probably super important for your test, but it's just nice to know what string can do. Then we also have lists, sets, and maps. I'm going to start with lists. So you're probably very familiar with ArrayList by now. You've probably used it a whole bunch of times. So the reason that these three things are put together as a single topic is because they serve similar purposes but organize themselves in different ways. So an array list always maintains its order based on your input. So if you add an item to an array list, and this one would be of integers, then it's going to be the first one you add, and then the second one you add, and then the third one you add, and so on, if you're just using whatever method adds to an array list. Also, you can add to an array list at a specific index. So if you want to insert into an array list at a specific index, let's say I want to put the number 4 at index 1, which would be the second slot. Then you can insert into an array list, and it will again maintain its pre-existing order based on how you added objects to the list. And then you can also remove from an array list. So let's say I wanted to remove at index 2, so I'll remove the number 2, and it will again maintain its order. So array list really is just a fancy container built around the concept of a linked list, which was one of your homework assignments. So that you should be pretty familiar with that now. Then there is set. And so sets are kind of complicated, and you don't really need to know what they're for or how they work in this class. I definitely didn't when I took this class. You just really need to know that a set applies a specific way of sorting the objects that you add to it. And there are different types of sorts for different types of data, and there are default sorts that are built into the language for pre-existing data types. And then there are custom sorts for custom classes. But just in general, know that a set is unlike a list, and that a list will maintain the order that you tell it, and a set will apply a specific type of sort to the data that you add to it. And then there is a map, and this one you have used before. So maps are built around the idea of key value pairs. So every key is associated with a value. So you could have something like the key is a string and the value is an integer. So you would make something like this, where inside of the place where you would have your generic type, you have the type of the key, comma, the type of the value. And then like the example that I use here is the key would be a name, and then the value would be an age. And you can use, let's say this is just like called name age. Then you could call get and give it a key, and it will return the value associated with that key out. You can also check if a map contains a key at all. So like let's say you're adding some pair of data to your map and you want to make sure it's not already there. You could do And then, if it returns false, then you could use the put method to add a key in value pair in. And then you can also use contains value to check if a value is present. The idea is that the key will always be unique, so you don't have any repeated keys, but you can have repeated values. So in this name age example, if you wanted every key to be unique, you could do something like your full name and then your age for the value, because a whole bunch of people are going to have the same age, but it's not likely that all of the people in a set will have like some pair of people that have the exact same name. So it's good for sorting something that has repeated values but not repeated keys. Did you ever go over iterators in depth in your class? Is it something that you think you need to know? I guess not really an important topic. I know you didn't ever use iterators in your homework assignments or anything like that, so I don't expect it to come up on the test. And if you never went over any serious examples of iterators, then I'm not really going to talk about them. I mean, I can say like the basics. A regular iterator can only cycle forward through a collection of objects, and it can only get the value of an object or remove it. A list iterator, if we're thinking about something like the linked list, it can move through the collection of objects in both directions, forward and backwards. A good example of this type of iterator would be like a scanner, where you can call like scanner.hasNext, and you can find out if the thing that's contained in the scanner has a next, and then you can call scanner.next if it's true. That's a type of iterator. It's the thing that takes you through the set of data that you're working with. A list iterator can also modify the objects that are in the container, and a regular iterator cannot do that. So yeah, I guess I'll just write down an iterator, like you've seen, that's built into the scanner, has methods like has next and remove, and a list iterator has all of those, as well as previous and has previous and set, which is the one that modifies the element. But yeah, you're probably need iterator stuff except what you've already seen with something which we're using now. There's some coverage in here about the built-in sorting types, which are called natural ordering. So if you were applying a built-in sort for something like numbers, then it's just going to be from low to high. If you're sorting something like strings, then it's going to be in lexicographic order, which is basically alphabetical order, like moving across the string, like you would find in a dictionary. Here's another topic that you have worked on in a homework assignment. Comparables and comparators. So a comparator is a separate class that takes two inputs that are both objects of the same type and does some kind of comparison on them, and then returns some associated value. For example, if your comparator is built to take two integers and the intent of your compare method is to say which of your two integers is bigger, then you could say right, there would be more to it than this. So if they were equal, you could return 0, and if num was less than num2, you could return -1. If you've used string compare and intro to C, then you know what this functionality looks like, where you want to find out if the first string is further along in the natural sorting order than the second string. It will return 1 if it is bigger, 0 if they're the same, and then -1 if it's smaller. So the main point here is that the comparator is a separate class that you instantiate to do a comparison between two objects. Comparable serves the same purpose, but it is embedded inside of an existing class. So if we think of the vehicle example, we could say that your vehicle class has this method in it called compare, and you want to find out which of the two vehicles has more wheels. So like which one is bigger. Then your compare method will only take one input. And it will compare the number of wheels inside of the current instance of the class against the number of wheels that exist in the outside instance of the object that you're comparing it against. So just on a bigger scale, what the difference between these two is that for a comparator, I guess I'll call this type like you would be instantiating a separate object that serves only the purpose of making the comparison. Whereas a comparable, let's say you've made a vehicle and then you've made another vehicle. And you want to know which one has more wheels, then you use the compare method that is built into vehicle. So actually, this would be int comp dot compare 1, 3. So you can see the difference here. And this one, you're working with 2 inputs using an outside class. And in this one, you're using the class itself to compare against another instance of that class. And this one is Comparator, and this one is comparable. Everybody good on that? Okay. Move on to monitors and synchronization. So a monitor is this thing that is built into all Java objects, and it has this lock, and what it does is it tracks whether your object is in use by a thread, so that if you create a multi-threaded program, your object can only be accessed by one thread at a time. And the reason that something like this exists is, what if you have this object that's shared data across multiple threads, and both threads try to modify it at the same time? Or one thread tries to modify it while another thread is trying to access it, and the success of the access is dependent on the data being the older value. So you might end up with a situation where you have this data in memory, and it had a value, and one thread is like, I want to change this value, so like erase it first, and then I'm going to write a new value in. And right at the moment where it erases the value, your other thread tries to read it, and there's nothing there, and you get some crazy result, or your program crashes. That's not good. So the monitor will say, if this thread is currently writing to my data, then my data is locked, and it will make the other thread wait until that change is finished before it can be read out. And even though this is something that's built in, the way that I like to explain it, if you were to write it manually, would be this. I do this really dumb, like water level example, where you have 2 locks, and this lock is the input side, and this lock is the output side. So in this example, this is based on one of the assignments that I did when I took this class. There's this shared data called buffer that is being accessed in sequence by 2 threads. One thread reads text from a file and puts it in the buffer, and then the other thread reads the buffer and then prints that text to the screen. They can't both happen at the exact same time due to the issue that you could run into if it's being modified and read at the exact same time. So the way it works is you have this gate that tells your thread to not do anything if the other gate is open. So you have some word here, and your program will set this value to false, and then this will be open, and it will read the word into the buffer. And as soon as it's done reading the word, it'll set the value back to true. And whenever this value is true, this value gets set to false. And it will open this side and read the word out and print it on the screen. And as soon as it's done reading the word out, this will get set back to true. And whenever this is true, this is running a loop that sets this back to false, at which point this will open back up and read the next word in, and so on. And so there's this dependency of Boolean values where every time one changes, the other one changes, and they're always opposite to each other. That forces everything to happen in sequence. And that is what synchronized threads are. So the best way I can explain it to you, because if I just say like, oh, this stuff exists and magically happens in the background and you don't need to worry about it, then I don't think that's incredibly useful. Okay, so this is the last major topic. This is supposed to go on for another 45 minutes, so we'll see how much longer I can talk for. Generics. So the example here is, let's say ArrayList. All right, so I guess the main question is, what does this mean? Why is there a T there? So generics are useful for two main things. One of them is for containers, like ArrayList, that contain objects of another class. And the other is just for methods that maybe you want to compute some value with. So for something like ArrayList, right, your ArrayList is always going to contain objects of some other class. And in this instance, all of the objects will be of the same class. So the reason that this is here is that every place where ArrayList works with the data that you're inserting into it, it will always refer to this value T. So when you instantiate an ArrayList, and you're writing what class you're working with in your ArrayList, it's going to replace every instance of this letter T in its class definition with whatever class you put in between the brackets here. So at runtime, it will change its functionality based on what you wrote. So no matter what class you put in here, it will always work with everything inside of ArrayList's class definition. And then the same thing applies to like writing a method. So I was talking about maximum earlier, like finding the higher of two numbers, and explaining my overloading example. You can see how it could quickly get out of hand, where like, you know, one int and one float, and then like one double and one float, and two ints, and then you have like a million different versions of the same method. Well, what if instead of doing that, you just use generic types? So you have this method and now I'm not going to write out like all of the functionality here, but you now say, when I instantiate whatever class contains this maximum method, so like in the example, the class is maximum test. I guess I'll write it up here. You can say like maximum test, max test. Oh, I wrote that wrong. I'll just go to the next page. And so on, right? You get the idea. So now I've written integer here in the brackets. So when the class is instantiated, this letter T will be replaced with integer, in every single instance it occurs. So this will now be integer x, integer y, and then integer max equals x, which is also an integer, and so on. So like every place you're creating a variable or using an existing variable, all of the types will match up because you've written them all as this generic type, which can become anything that you choose to write when you instantiate the class. And that's pretty much everything for like going over all of the main topics in the class. I guess we can look at some sample problems, or if anyone has any questions about things that you think might be on the test, or like things that you worked on during the class that you're not sure about. Yeah.
Static.
Okay, yeah. That was, for some reason, that is not covered in any of the review slides, but let's talk about static. Okay, so static is a keyword that refers to any data or method that does not depend on things in the class that will change after you instantiate it. So static methods can be called without instantiation. So what this means is you have this class definition. And it has some data, and it has some methods. And one of the methods is, I'm going to come up with something really stupid because I'm terrible at thinking of examples. Right, so this method will probably look something like this. And I know this is really dumb and really simple, but it gets the point across, which is you don't need to instantiate your class to make this work because it doesn't depend on anything that would happen when you instantiate the class. So like, let's say you have some data in your class, that's some number, and you have some method whose purpose it is to return your no, this would be an int, right? Your private data that doesn't have some predefined value. Right, this can't be static because you have this integer that doesn't exist yet that you're using to make a calculation. And the way that you would make it exist is have a constructor right, that assigns some input value when you make an instance of this class, so that this method can actually do something, right? Which is compared against this static method, which has no dependency on a successful instantiation of the class to do what it's supposed to do, which is just return the integer 5. So the way that you would call a static method without making an instance of the class is if the class name is stuff, like I wrote here, then you can just, as long as the class is part of your package or you've imported it, you can just write the name of the class itself instead of making an instance and then referring to the name of that instance. You just write the name of the class and then the dot operator and then the name of the static method. Right, and then static methods can also refer to static data. So let's say I have this return 5 static method, and instead of saying return and then the literal value 5, I have some integer that is static and its value is 5. So its value is unchanging, and I can refer to it in my static method because the data is also static. And so I don't need to make an instance of the class because all I have to do to find out what this does is look at the class definition. I don't need to allocate memory and put variables into that memory for this to work. Any other questions or topics that you want me to go over? Okay, let's see if there are any decent sample questions that are on here. The first one is about input-output. I'm going to read it and then decide if it's worth going over. Write a complete Java program to prompt the user for 3 integers from the console, compute their average, and output the results as a decimal real number to 2 decimal places, followed by a new line. So this is a combination of knowing how to read input from the user using a scanner and system.in, how to print to the screen using system.out.print, and then just using formatting code, which, if you've taken Intro to C, then like using the %, like %f would be for a float, and then the decimal is used to say like how much space that float can take up, and so on. Nothing like that will be on your test. I'm fairly confident. That's intro level stuff. Here's one about just doing basic arithmetic stuff like order of operations. We don't really need to go over that. Being able to follow what the output of a looping program is, like how many times a for loop should run, that's also intro level stuff. Okay, this one is about collections. This one is worth going over. I wish I had some way of displaying my screen. Will this work? Kind of. All right, let me do this. Is that legible? I think I'll just write it out. And then I'll just shorthand the main. and also shorthand the prints. So what this program is supposed to do is it creates an array, a 2D array of strings, and it's going to contain two. I need to look at the rest of the question. So it's going to make an unknown number of rows, but it will be, I guess, 2 columns if you're looking at it this way. And it calls method 1 and method 2, and then wants to print length is, and then the length of the names array. So, oh, this is really long. I don't know if I'm going to be able to write all of this out. Have you gone over these in your class?
Yeah.
Okay.
There was a confusion though if like there was a typo with the order of that it printed out. Like I think it's supposed to reverse print order if you look at the answer.
Yeah. So first it prints
Like it's supposed to be
names at 0. Okay, yeah, just give me a second to look through it. Okay, so first it creates a list of strings containing Mo, Larry, Curly, and Shemp, and then it calls collections.sort on that list of strings. So, like I said earlier, it should sort them in alphabetical order when you call sort. And then it creates an array of strings size 4, and then calls get on that list of strings in a loop going from 0, 1, 2, and 3. So the assumption here is it just prints them in alphabetical order, which for method 1 it does, right? Curly, Larry, Mo, Shemp, that's alphabetical order, right? In method 2, it creates a set, which is a hash set of Groucho, Chico, and Harpo. I love Gleanos' examples. They're so relevant to the times. And makes an array of 3 strings, then creates a tree map with the key being an integer and the value being a string, then runs a loop on the set of strings and places each of the strings in the map one at a time in this for loop. Then it says keys equals key set, iterator equals keys iterator, and then iterates through the map to find out what order they are in the map. I don't know. This is a complicated question, and it would take me forever to write it all out. But I can pretty confidently say you're not going to need to know like putting something into a set and then moving it from a set to a map and then like iterating backwards through the map or like something silly and ridiculous like that, you're not going to be tested on it. But like at least knowing like the default sort for strings, this alphabetical order, is pretty straightforward and not super like this question would take too much time to realistically be on a test. Also, you haven't had anything like that on any of your tests, have you? Like you've never been tested on like sorting types for different types of collections. You have or you haven't? Okay, yeah. So then it's not your. And what I know from your professor and what you've covered in your class, you're not going to have that. Because all of these slides are from when I took the class, and I know that the content of your class is different since you have a different professor, but my professor is the one who made all of these slides. So I don't even know how relevant these sample questions are, because I don't know what the questions on your tests were like. But they were probably nothing like the stuff on the slides, if what I've heard is correct. But that's all I have to work from, because that's all that's available to me. There's a question about comparators, but we went over that pretty thoroughly. So you can probably handle that one. When you went over it in class, was it pretty straightforward? I'm trying to think if there are any other worthwhile topics. I can come up with some, I can look back at some examples of some of the stuff that I've covered already that I didn't write any specific examples for. Let's see, I've done that.
Do a generics example, since that's the newest thing.
Sure. I'll just use the one that's on here. So there's you never talked about wildcards, right?
We did, but it was like, okay.
You never did any like serious work with wildcards. I was never tested on wildcards. I've never written one in my life.
It was implied in my pie chart one, the histogram pie chart. That's not good.
Okay. So yeah, we can look at the example for a generic class. Okay, so there's this class called box, and it contains an object called objects. Object is like the most basic type in Java. It can work with pretty much everything, but it also has no specific data. Then there's a string called string, and then we have its constructor, which takes something of type t called x and assigns that x to the object variable, and then assigns the string version of x to the string variable. So you can see why object is of type object, right? If we have generic type t, then we have no way of knowing what class it's based on. But since object is the most generic type of all, that means that any class can be assigned to an object. And then most classes can be converted to strings. There are probably some that wouldn't work. But in most cases, calling to string, converting whatever the primary data of that object is to a string, and then assigning it to a string would probably be fine. And then we have this get method that returns type t and just returns the object as type t. And then we have show, which just returns the string for probably printing purposes. Right, so the whole point of this thing is that the class itself is of generic type t, so that anytime you instantiate the class, you choose what its type is, and then everything in the class will work properly because you've made the type generic. So I could do, let's say, string. So I'm going to make a box of type string. Right, and in its constructor, I'm going to place the data that is relevant and matching to the type that I've chosen, so that the containing data holds on to whatever I've placed in the constructor, right? So this constructor is expecting an input of type t, and in this case, I've selected type t to be a string. So when this actually runs, it's going to expect a string. And so I've appropriately given it a string as input in the constructor. And then it will assign that string to object, and then it will also call toString on that string and assign it to string, which is fine. We just have two of the same thing. And then if we call, let's say we do a call to print, and what we want to print is sbox.get, because in this case, we know that the data in sbox is a string because we made it a string and gave it a string. So we can be pretty confident that when we call the print method and then we call sbox.get, oh, this needs parentheses, right over here, the get method returns type t, which we've set as string here. So it will return a string. And what it's doing here is it is casting the object data to type t. So t, again, will be replaced with string. So it will return object cast to string through the string type return. So we will just get back object containing this data, and it will print hi, the string that I wrote. And then if we called, again, the show method here, well, we converted string x to string and stored it in string. So this will actually do the exact same thing. But in this case, string is pre-written here. It's been specified that show will only return a string because we've modified whatever this data was, converted it to a string, and saved it as a string. So it'll return whatever the string version of what we give it is, which in this case was already a string. So these two will do exactly the same thing because we've specified the generic type to be string and replaced every instance of t in this class definition with the class string. I believe there is one more. Do you want me to do another generic type example, or are you good on that?
I just have a question about this one.
Yeah.
So what you're doing is you said you were casting the object.
Yeah.
Okay. Just wanted to like get a general summation of it all.
Yeah, so whenever you write a type in parentheses next to the name of an object, that means you're attempting to convert that object to that type.
Okay.
So in this case, no matter what t is, we will always attempt to convert object back to t when we return it out of the get method, because right now it's that super generic type object. And so if we didn't have this here, and we tried return object without it, then the type of object would be object instead of t. And so this, you couldn't even compile this because you're returning a type mismatch. Let's see if there's anything else in here. I can write a more thorough example. I kind of already went into the comparator and comparable thing. I guess I can do an iterator example, even though you haven't really done it in class or on your homework. But it's probably the biggest topic that I haven't shown an example for. So I'm not going to write out the whole thing, but there's a class called test iterator, and it has a main, and inside of its main, a list is created, and a bunch of strings are added to the list. And then there's a show method and a no p method, which removes the p's from the strings before printing them again with the show method. So I'm just going to write the two methods, show and no p, and you just know there's a list called list with a bunch of strings in it. Right, so the first thing to notice here is we're instantiating an iterator of type string called it, and its constructor exists within the list class. So we have list imported, but we're actually calling list.iterator to create the iterator. Well, like normally you see a constructor, and the constructor is just the name of the class. In this case, this is an iterator that is specific to the list class. So to construct it, we're calling the list-specific iterator constructor. And then here you can see it.hasNext, which is just like when you're working with a scanner and the scanner's iterator. So we have this while loop that says, while our iterator is aware that there's another object in the list, then get the object in the list by calling next, save it in a string, because our list is a list of strings, and then print the string and a space. So this will loop, printing alternations between the string and the space until hasNext returns false, meaning there are no more strings left in the list. And so ultimately, the print is just all of the strings in the list separated by spaces, followed by a new line. Or actually 2 new lines, because println makes a new line and /n also makes a new line, so it's 2 new lines. Amazing. And then there's this no-p method, which once again creates a list-specific iterator. And once again, we have this while loop structure of while there is a next, then get the next and assign it to a string s. And then here it says, if the first character of string s is the letter p, then remove it from the list, right? Because Iterator has the ability both to walk through the collection and also remove items from the collection. So just to like specifically analyze this line, right? Character.toLowercase would be a static method because character is just a class name, right? So it'll just take whatever character you give it and convert it to the lowercase version. And it says s.char at 0. So that means char at 0 is the first character, like at index 0, right? The very first character in the string s. If it equals p, then call remove. So the sequence of calls here is, so we have in the list apple, pear, orange, banana, and plum. So if we call just show first, it's going to print all of them. If we call no p, it's going to go through the list and remove every single string that starts with the letter p and then show is called again after that, and this time it only prints apple, orange, and banana because pear and plum start with P and have been removed from the list. So yeah, iterator is pretty straightforward, I think. Next has next, remove probably won't get much more complicated than that. There is a list iterator example, which is a little bit longer. And let's see, what are the differences here? So the list iterator example is just showing that it can modify the contents of the collection. So it has the same structure here, but instead of no P, it just converts the first letter of each of the strings to uppercase. So it's just saying like while list iterator.hasNext, it gets the string from the list by calling list iterator.next, and then sets the string to the same string, but it calls to uppercase on the first character, and then calls list iterator.set on the modified string to replace the string that it's currently looking at in its place on the iterator with the modified string. So there's also some extra stuff about synchronization. I said it earlier, but I'm just going to write it out. If you want to use that locking mechanism with the monitor that's built into every object, then you use the synchronized keyword. Oh, it would help if I could spell. So in a case like this, having the synchronized keyword just means that none of the data that exists inside of this method can be accessed by more than one thread at a time, which, if you're writing a program where your data is being accessed by more than one thread, you're going to want to use that. Otherwise, you have to write the whole manual locking mechanism like I explained. Let's see if there's anything else worth writing down. Don't forget, when you're writing a character and you're defining what the contents of a character are, you're using single quotes. If you're just defining a string and you're writing the contents of the string, you use double quotes. The break statement will end a loop if it's encountered. So if you see something like this, right, so here we have some index variable that gets added to every time the loop runs. And also every time the loop runs, that index quantity gets added to a sum. So like the first time sum is 1, the second time sum is 3, the third time sum is 6, and so on. And eventually sum will be greater than 100. and we will encounter this keyword break, and a break will just end the loop and move the program on to whatever the next thing is after the loop. I don't know if that'll be on your test or not, but it's just some general programming stuff. I don't know, I feel like I talked about pretty much everything you've done in this class, at least in a more general way. Like, hopefully this helped. That's everything that was provided to me that's supposed to be coverage for the final. Any other questions? I'm supposed to tell you there is this survey. You can like scan the QR code and tell them how terrible of a job I did. So yeah, you can do that if you want, or not. I don't know. Good luck on your test. I know this class has been pretty tough. The best recommendation I can give is go back to all of your homework assignments and just make sure you understand everything you wrote. Because realistically, like, even though I talked about all of these topics and I gave at least some decent examples, the stuff that's going to be on your test is probably going to be stuff that was either on your homework or in examples that you've seen in class that weren't here. So just like be really confident about the code that you've written and be able to write it again in a test environment. Like, that's the most important thing. Like, tell yourself that you know the language, you know the stuff that you're writing, you're confident in what it's going to do. And just be careful and work slowly and reread your lines of code, check for errors, make sure you've written everything correctly and ask yourself if it does what you think it does when you're done writing it. Because that's usually where people go wrong during programming tests. It's not that they don't know the material. It's that when they're pressured for time, they write code and then don't check that it does what they think it's supposed to do. Because it's happened to me plenty of times. If there are short response questions, like at the very least, you know all of the topics and what everything is supposed to do. And also, hopefully, I covered like what the purpose of some of these things are, like why object-oriented programming is useful for not just organization and reuse, but also for working with other people on teams, because if you do end up getting a job programming, you will not be working by yourself. So understanding why this environment is useful and that you'll be working on stuff that other people aren't working on, but it also needs to work together, and you'll be using other people's code all the time and what you're creating, and you need to be familiar with how to access other people's code and what it's used for and what you should change and what you shouldn't change. That makes sense of all of this stuff that you're learning in this class. And I guess I'm done. Thank you for being here. I was amazed at the turnout. I wasn't expecting more than one person, and I got maybe like 7 total, which was incredible. I don't know if anyone was watching online. I'm going to guess not. There's another, so this class has another review session tomorrow at 10 a.m., which is being held by Bridget, the other tutor for this class. She's really awesome. She's a million times smarter than me. She's done this before, unlike me. This is my first time doing this. So she probably has a more thorough review than I did. But also, she was in charge of all of the students